Let me now introduce just an additional theme, how the realm of natural structure and spontaneous formation process has historically inspired architectural thinking both formally and functionally. This branch of research that some of you already talk about and which is well represented by the group of Fraiotto, look at complex form as an integrated intelligence where the interactions and the codependence between formal and functional factors are productive and bring to higher forms of organizations. Studying these models is the cultural premises for a method of simulation that try not much to replicate literal forms, but rather to reproduce system of relationship where the genesis of a specific ended forms is the synthesis of reiterative steps and intertwined process. Choosing an organizational model implies as well specific format decisions. In our case, we choose the honeycomb structure, which is not only a beautiful hexagonal pattern with an efficient way of managing energy and material, but is also a functional system of social cooperation with an excellent balance between top-down and bottom-up forces. Also, our architectural prototype tried to challenge metaphorically and structurally concepts like tolerance and collaboration. Tolerance adopting the cardboard properties which is stiff but not rigid, and collaboration relying on the mutual dependence of small individual elements for the overall stability. From the diagrammatic and the material investigation, we obtain a sort of list of programmatic, geometrical, and material constraints. In particular, in order to achieve the double curvature differentiated along the whole surface, we use a constructive system based on rigid triangles of corrugated cardboard following the honeycomb structure. This system is the literal example of what we mean by geometrical tolerance. Indeed, here the differentiation in curvature is achieved arranging three different basic pieces, and according to the material quality, by deformations and allowances. A piece have a strong curvature, B piece form a slighter one, and C pieces form a plane surface. As a rule, we adopted the idea that only adjacent pieces, so A and B or B and C, can be joined together. And in this way, with the simple combination of those triangular elements, we generate 5 degrees of curvature, and by approximation, we could shape the whole differentiated surface. The overall curvature was controlled by 2 models, scale 1 to 10. The first model was directly built from a digital model with the help of a laser cutter. But in this 3D digital surface, we did not provide the best structural and operational performance according to our material properties. So the second model, by approximation, reproduces a similar curved surface by using the constructive system previously described. From this model, we also could generate what we call the map of components that help to freeze the internal relationship and to define the prefabrication strategy. Although the map crystallized the configuration and made the prefabrication process manageable, it kept the final shape flexible in order to absorb those indeterminate yet expected factors rising from any building site. In this sense, the map acts as a genetic code that establishes fundamental rules while enabling geometrical indeterminacy at the level of the components. And I come now to my conclusion. The morphogenetic process was a constant and dynamic equilibrium between deterministic decisions and self-organized effects. Both in the diagrammatic thinking and in the honeycomb structural system, we postpone the form definition and we tolerate temporal adaptation and adjustments. For example, since the contact between the cardboard faces was designed as punctual connection, the honeycomb structure and pattern under the gravitational forces evolved and generated a star-like pattern, which was completely unexpected and create this sort of three-dimensional mosaic. Similar to what is happening both in architecture and contemporary architecture and engineering, this academic experiment tries to merge education, research and practice in a regime of complexity. And possibly small-scale, lightweight construction and simple assembly techniques are the premises for an understanding of the discipline that can reduce the gap between ideation and construction, while hopefully earning new geographic, economic and technological dimensions and meanings. Thank you.